Hello, my name is Andrei. Welcome back. In this video, I'll talk about LangChain pipelines, and I'll show how to run LangChain pipeline on local CPU with Ollama. And yeah, let's start and see the code first. And first of all, maybe let's discuss quickly why actually it makes sense to run pipelines on local CPU, invoke LLMs on local CPU. So the main thing is data privacy, because lots of companies, they don't want to expose the private data to cloud, and they prefer to run LLM pipelines or workflows on local environments, and it can be either CPU or local GPU. But with the option of running pipelines on CPU, it's even better because there are more choices, more options to test, and so on. And by the way, Ollama is not just one way to run LLM models locally. There are other libraries like C Transformers library. You could use it with Python to run LLMs locally. Then there is Llama CPP Python. This is the Python wrapper library around Llama CPP. It also allows to run LLM models. Then through Hugging Face API, you can run models locally, and maybe there are some other options as well. But based on the test that I did with different libraries and options, so far Ollama looks the most promising to me for a couple of reasons. First, it's very easy to maintain and manage the entire flow, because it resembles the Docker. Basically, you install Ollama desktop application, and then you pull different LLM models from the central repository, and you can delete those models easily with a single command. And then you can use Ollama inside your, for example, LangChain application, and even you don't need to install Ollama client inside your application separately. It comes automatically, for example, with LangChain. Also, it's possible with to run Ollama with Llama Index, and you can run Ollama directly if you want with Ollama client from Python, or you could run Ollama from the command line. Okay, so let's see the code. So what we got here, Ollama Invoice CPU application. The source code for this application is URL for this source code is available below the video. It's on the GitHub. You can download it and run it on your own environment. And the main idea was to keep it simple, and so that in the future, if API would change, for example, LangChain API would change, or you would like to plug in different vector database. Currently I'm using ChromaDB, so that you would be able to replace and change the code without too much hassle. Okay, so in the main script there's a main function, and what we do here, we read the input which comes from the command line, and then we call a helper function build rack pipeline. And we get back the LangChain object here, and then we call another helper function get rack response. We pass the input, and we pass LangChain object into that helper function. And then we print out the answer. So if you look into this get rack response function, it's over here. What it does, it's using input, and it sends it to the LangChain, and LangChain communicates to the LLM model, in our case through Ollama. There are other options, but in this case it's on locally through Ollama, and from LLM it gets back response, and the response comes with some description text and with JSON, because I'll show you later that I'm constructing a prompt in a certain way where I'm asking LLM to return actual result in the form of JSON. This is one of the options, and I know there are other options available. For example, Ollama out of the box could return JSON structure, and this is being implemented. Support for this is being implemented in a LangChain, and soon it will be available. Then we'll test this approach. For now, I'm using this simple approach where I just ask LLM to return JSON response, plus it returns additional description text, and in this function I'm just parsing out this description text. I'm getting just JSON fragment and converting converting this string, which looks like a JSON fragment, converting it to a JSON object and returning it back just to the user. Okay, and let's look into the build RAG pipeline function. It's over here. And what we do here, we load embeddings. And in this case, this is for this function, and we're using ChromaDB over here, and we're using from ChromaDB, we're getting a retriever, because ChromaDB keeps ingested data from our document, and we're getting retriever, and retriever basically returns from the vector DB, it returns the content which will be sent in our RAG application. It will be sent to LLM to produce the answer from this content. In our case, this is invoice document. Then we load the template, standard template for the LangChain, which helps to communicate with the LLM. And then this is the main thing, just a single line of code over here is this one. So from Ollama, and we're getting Ollama from LangChain LLMs, because Ollama is officially supported by LangChain. We're passing model name, verbose false, temperature 0, and we get back the LLM object, which is supported in all LangChain standard pipelines. And then we're saying that load QA chain, and we pass retriever, LLM, and prompt. And this is the helper method, which constructs retrieval pipeline from LangChain, and it's using this LLM which runs locally and it was loaded through Ollama. As I mentioned before, there are other options, like you can use C transformers or Llama CPP Python, for example, but based on my experience, Ollama provides so far the best experience. Additionally, I like Ollama because somehow it works much better with LLM tokens. For example, I can pass, for example, longer input, and also I can get longer output from the LLM. And this is not the case with C transformers. For example, if response is supposed to have more data, longer JSON, for example, object, then it returns error that maximum number of tokens is exceeded, even if I increase number of tokens. This was not happening yet with Ollama, and I'm quite happy about that. So basically, it's to use Ollama with LangChain. It's a single line of code, and we're passing name of the LLM. And in this example, I'm using Starling LLM 7B alpha, and it's quantized model with 5 bits. And then if you look into the example, then I was very surprised that this specific Starling LLM returns quite good answer for this question. For example, to retrieve gross worth values for each invoice item from the invoice table and format in this kind of JSON style. And there are 4 invoice items, and for each of the invoice items, correct numbers are being returned. And if I look into that, we'll see that it's over here. So we got 1, 2, 3, 4, and all those values are correctly extracted. And this prompt was not working, for example, either with Llama 2, Mistral, or Zephyr, but with this model, Starling LM, extraction was successful, so that sounds very promising. And then another prompt which is not working with other open source models, for example, to get description names of all invoice items, and in this case it returns correct full text for all the invoice items as expected. Time to retrieve is around 1 minute and a half. That's because I'm running it on my local CPU, which is Intel i9 MacBook. If I would run it on M3, for example, then Ollama out of the box would use GPU acceleration, and I suppose that response will be much faster. I should test this on the newer machines. Okay, so that's about Ollama, and yeah, the beauty of it is that it's just single line of code and you're good to go. And if I go to the command prompt, I could say that I could communicate with Ollama through the command line, because Ollama is like a desktop application. For example, it runs here. And it's a nice thing that when you get new versions being published, then you automatically get indication here that there's a new version and you can restart to update it. So that's quite nice. And I could say Ollama list, and this brings the currently downloaded LLM models on my machine. So I have Starling and Zephyr, for example. And I can also, if I execute just like that, I get, you could do like surf, run, and so on, pull, push. So if you even don't need LangChain, you could run LLM model from command line and interact with this model through REST, for example. Okay, so thanks for watching, and in my next video I'll try to test Ollama with another LLM framework like Llama Index, for example, and I'll see the differences with LangChain, and because I'm evaluating for myself what I want to use, either LangChain or Llama Index for my use cases. So stay tuned, and see you next time. Bye.